How many people know who Joyent is, what Joyent is? Look at those hands, this is awesome. Alrighty, Boyd, thank you, by the way, for organizing this, and thank you all for coming here. Let's get into it, because I like this crowd already. You know, y'all great looking people, in fact. All right, so a lot of people know Joyent, and so who am I? I joined Joyent earlier this year. I was a Joyent customer before that, and it's how I learned about the technology and why I got to love it. We're going to dig into those details over time, but the reality that I was using it for a number of years got my start with Joyent using the cloud on a USB stick keychain and running a hybrid cloud, our data center and Joyent's data center. In fact, so let's actually just, I got to cover these slides that the marketing folks give me. So back to that. All right, so Joyent, it's all about your favorite code, your favorite frameworks running on the best infrastructure that you can get. And what do I mean by that? Well, first of all, it starts with your data center or ours. And so we build software that manages our data centers from bare metal all the way up to providing services. And we offer that exact same software to run in your own data center as well. So you can have API identicality between the multiple data centers. So it's really easy to do hybrid clouds. But more importantly, perhaps with some of this conversation, is that it's all totally open source. Easy to install yesterday. What was the timeline to get it installed yesterday? What's that?
34 minutes.
34 minutes. I like that number. I think you're giving me credit. I think it may have been a little bit longer, but I like it. So yeah, open source, install it, run it, and have yourself a container environment. You may also know about Joyent because of our involvement with Node. We are the corporate stewards of Node and the creators of the Node Foundation. But we're here today to talk about Docker. And wow, jumping right past that slide. We're here today to talk about Docker. And by now, I think everybody's been Docker washing for about a year. Does that sound about right? About a year now? Yeah, maybe 6 months, 2 years. What was that? 2 years. 2 years. Okay. But you might ask, why do we love Docker so much? Big. There we go. So if we look at how Docker works, right? Joyent has been doing containers for about 10 years in production. We have, we think, the absolute best container runtime. So it gives us things that you can't get elsewhere. But that's not good, right? In the infrastructure. It works data center scale. We've got proven security, really good networking that you're not going to find anywhere else. But on the images side, and honestly the piece that developers like in some ways, we didn't build out the tool chain that we now know is fantastic in Docker, and it was machine-centric rather than application-centric. If you take Docker and you look at what they're doing, that tool chain is fantastic. The notion of building in an application-centric way is really cool. But on the infrastructure side, it doesn't work out so well. There's a lot of things lacking when you try to take Docker to production, and you see that it just kind of, it's not what you want. There's a lot of stuff that you have to build out to get it there. So if you take the good, accentuate the positive, cut the negative, you get something that works out pretty well. And so can we combine these things? And the answer is, we think we can. And that's why we love Docker so much, because Docker solves problems that we hadn't solved on our own, and we're solving problems that Docker has as you try to bring it in production and use it at scale that we don't see a clear way to solve any other way. So how many people are using Docker in production? I like this. So we have maybe twice as many hands as last time I asked that. Now it's been at least a month. And so that's good. That's good. Similar size crowd too. So 4 people I counted in this group running Docker in production. So I'd say that's less than 10%. How many people have tried Docker on your laptops? Right. Okay, you love it, right? There's some really cool things about building Docker on your laptop, and there's a lot of things that seem so wonderfully easy right there in that environment, where you're not worried about security, you're not worried about multi-tenancy, the networking problems, you're all right within the same host, so you don't run into the networking problems. Docker on your laptop is fantastic, and you can wonder, why the heck can't we do this everywhere? Well, the first problem, of course, is that suddenly as you go to the cloud, you get into the security problems of containers. Jerome, this is his slide exactly, but even more importantly, I think, is the Travis CI thing, where they explain that they're not giving sudo to people because Docker containers have known vulnerabilities that they just can't tolerate. So they're having to restrict their environment in ways that they weren't doing elsewhere. Of course, the next thing is that networking is kind of a pain in the ass with Docker. How many people are suffering bemoaning Docker networking? Okay, more people that are running in production, though not exactly the same hands, which means some folks have figured out a solution there. But a lot of things that you got to do, you end up having to, you've got a network in the cloud, then you bring the network and virtualize it into the Docker host, and then you have to virtualize the network again to connect your container inside that Docker host. How many virtualization layers are you going to add to your container before it can get out there? And what, of course, does that do to your performance? Already hampered if you're in a virtual machine. But I'm getting ahead of myself by talking about virtual machines so much. What we do, because we run our containers in an environment which gives you, gives you one or more network interfaces per container, you've got that solved, I think. And then host proliferation, where you're trying to run not on just your laptop, but you've got to deploy across dozens or hundreds of hosts. That can be a real pain in the ass, and we think we have a solution for that too. And so we weren't alone in this. This is actually back from January, where let's see, who is this? What is it? Peter Levine or Levin. He figures that what we need is just one giant computer in the cloud. And is there a way? Could we possibly virtualize that? And we like that idea. We liked that idea so much and so long ago that what we were working on is what we're talking about today. And so we've actually been in release for a little while. I'm going to be really proud to show it to you. But in order to understand it, what I want to start with is the container anatomy, because that is core to understanding how we're doing the things, solving the problems that we're talking about. And so we all know this, right? A container is both the application package and the runtime environment, right? Of course, in Docker, this is called the execution driver. And it used to be LXC, then it became libcontainer. Of course, CoreOS got excited about this, tried to fork the ecosystem, created runC, appc, and then of course it all is coming back together under runC. And so that way that you can take up the container, you can just swap out that runtime environment, right? And so by doing so, if you swap out that runtime environment, you get to do some stuff. How many people know what SmartOS is, though? All right. What was your experience with SmartOS? I don't want to hear that. No. Because what I want to talk with you about is whatever that experience was, it's a really interesting story, because the new Joyent and what we have with Triton, you don't have to worry about SmartOS. SmartOS is the hypervisor, right? I don't like to use the word hypervisor because it gets to confusing things, but you're running on bare metal, and SmartOS is what keeps those containers safe and isolated, and virtualizes the network interfaces and the other resources. But it's not what you're running inside the container, right? And so if we look at the story I'm telling here, if you take SmartOS, which is really fantastic as the underlying host operating system, really lightweight underlying host operating system with fantastic network virtualization and containerization, the kind of stuff that you want at that level in your stack, you're fantastic. But the truth is it's not Linux, and if you're trying to use this as the operating system in which your applications are running, there can be some frustrations. You can't always Google your way around some of the problems, and so let's play this game again where we look at the positives and the negatives, strike them out in different ways and combine them, and what you get is what we've done to solve it, right? And so we're taking Linux and SmartOS and combining them in one. It looks a little bit like this, where you take the SmartOS kernel and wrap that with Linux system call translation, so all of your Linux binaries can run in this kernel, so you can enjoy all of the advantages of that kernel and all of the advantages of using the Linux binaries completely unchanged at bare metal speed. And so because we can eliminate the hardware virtual machine in this environment, run those things at bare metal speed, the performance jumps dramatically, especially for I/O operations, because you're removing those jumps from the guest OS into the hypervisor to do all of your I/O. You're removing multiple schedulers to do all of your compute in I/O. And so you get a lot of performance gain just by getting on bare metal. And so we enjoy the SmartOS kernel, Linux system call translation, your binaries, your apps running unchanged, and then the internet outside that. And so we like how this works. It seems other people like how this works.
You need to press that button.
So you ain't got to worry about the stage is simple.
No, you just stay, you go.
Damn it, that motherfucker accelerated
65 miles an hour.
So
Right
I didn't
there.
realize we were going to have audio on that.
This is faster than McLaren on the start. There we go.
I didn't realize we were going to have audio on that, but somebody tweeted that that's. Did you want the video or did you want the so somebody tweeted that what it's like to run Linux binaries on SmartOS. The performance is unbelievable, just like getting into the Tesla insane mode and accelerating to 85 miles an hour in, I don't know what it was, half a second, something like that. And so, where does that get us? That gets us to what we call container native, right? And this is where we want to be. When we're working with our application containers, we want to be in a situation where we're dealing with the containers and not messing with hosts. So let's eliminate that host cost. All right, but what do I mean by container native? What is that? All right, so you can sort of tell but container native by seeing what it's not. I don't like to talk about competitors, but if you look at some of this stuff and you look at some providers and you look at what they're charging for, when you realize what they're charging you for is not the container but the underlying host, you have to wonder if what they're doing is trying to support legacy businesses. And you're like, wow, that business is just 10 years old. How is it legacy? Well, containers, that's brand new technology that is totally disruptive to what we're doing. That's why this room is nearly full with people interested in it. All right? And so, are virtual machines a legacy technology? I think so. So why are we paying for legacy technology when we're trying to run the latest stuff? You know, and we're not alone when we look at AWS. A few other people. Here's another approach to it, and you can configure a whole cluster. Well, why are you paying for a cluster and paying for virtual machines to run those containers on a cluster? You want a whole data center on which to run your containers. And you don't want to pay for the virtual machines until you start using the containers on it, right? And so again, hey, here's another one. I'll tell you what, I'm absolutely not going to get to Rackspace with this game. Would not do that. But if you look at Google Container Engine, right? What are they charging you for? Why is everybody charging you for a virtual machine when what you want to run are containers? That's just unbelievable to us, right? And so what we think is, if you're building containers and deploying containers, your unit of compute needs to be a container. You need to provision containers, not virtual machines, not manage virtual machines, right? And you need to have your containers run on bare metal. That's what container native is. So you're running them on bare metal, not VMs, and you pay for containers, most importantly, not VMs. Why does this matter? Well, because, man, I'm afraid the video is going to be all noisy again, too. But running your containers inside VMs is slow. It's like having them stuck in the mud, so don't do that, truly. The performance loss, and anybody who's browsing the Joyent blog, you'll see the performance loss of running inside a hardware virtual machine is tremendous. You lose a lot of performance. And so the gain that you can get is really great. If you're running your own data center, the gain in density, in utilization that you can enjoy to reduce the number of machines that you need total is a very significant thing as well. But there's another problem here. There's another thing, and music. Is there any way to slow this down? So there's this Tetris problem with a container. When you're trying to put the containers in the VM, right, you end up creating these buckets in which to fit the containers, and to fit them there, it's like playing Tetris with data. The problem is you pay seriously every time you make a mistake, and you pay when you try to solve that mistake. It gets really painful. Let's take a look at this app just as an example. This app just happens to have 4 containers, and here we are on putting this in a VM. It maybe works in the VM. And it fits until you have to scale it, and then you're like, oh man, now I need more VMs, and it doesn't fit too cleanly in all those VMs. And so if you look at the amount of stuff that you're paying for that you're not using in that VM, because those VMs, they come in fixed sizes, your containers don't necessarily use all of them, fitting them around. Again, this is like playing Tetris. If you're paying just for those containers that you're using, not for underlying VMs, you don't pay for wasted compute resources. That adds up. That adds up to a lot. So this is how container native can truly save you money. I'll take questions. I'll be heckled.
So I have an inherent problem with that argument. Because yes, you can pack a lot more stuff on there, but what never seems to be acknowledged is you have to rethink how you do capacity planning at that point. Are you going to talk about that?
I think so. I think so. I think capacity planning gets easier, but what we call this, our container native platform, we call this trite. And so this is what Joyent has brought to market just a month ago in general availability. Before that was in preview. Andrew was asking if anybody had tried the preview. Now it's in general availability across a number of data centers. And so this is what we've done to solve it. I think one of the most exciting things here is going to be a demo, but let me point out some of the things that we want to look at when we do that demo. First thing is, let's do this demo, because it's going to be more fun, especially with the questions. These are not my slides. Let us do that.
By the way, that question was me enabling you all to ask questions too.
Yeah.
In case you missed that.
So how do you price the resources consumed by a single container?
That's an awesome question. It is on joyent.com /public cloud /pricing. It's each container is priced individually, and just think about it like it's a VM.
It scales continuously. It's not like there's a 4 gig container or a 6 gig container.
Let me show you those. Let me do this. Alrighty, so pricing. So we scale, we have containers as small as 128 meg, and it does scale in some groups, but you get these tiny containers. You can't run a VM with 128 meg really anymore. Yeah.
Can you zoom in?
That makes sense.
A couple times?
No. Well, that's what it is. How's that? So you run that smallest container all month, you're going to pay about $2.43, I think, something like that. And so you don't have to pay for a lot of containers. All right, so let's do this.
It's also by the minute instead of by the hour.
So yeah. All right, so we're waiting. Hey, was that Aaron from Docker there?
Yeah.
Yeah. Hey, so we're waiting for a couple of pull requests to be merged.
On that.
But until then, what we've got is this helper script. You download this helper script, you give it some information. We use your SSH key. We transform your SSH key into a TLS certificate. Your SSH key, when it's used by the script, never leaves your computer. And then we write out a thing that you can source to set your environment variables. It also gives you that information, and I'm writing another environment variable. But so when you run that, what we get is we get this screen. So basically, it takes that information, tells us what to export, or you can do as I did and just source a file that it writes, and you should be good to go. At that point, we can do a let me zoom in here. And so suddenly, you're using Docker, but we're talking to Docker in our cloud, right? So what are the things that look different here? First things first. We're using execution driver. Who's seen that execution driver? What operating system are we using? There it is, Smart Data Center. Kernel version. All these things were just made up, sort of. I mean, they are real, but you can tell if you look closely that we're not talking to Docker. I mean, first of all, we're not talking to Docker on our laptop, and we're not talking to Docker that we're familiar with. We are, however, talking to Docker in the cloud, right? And doing a doing a Docker run is just simple, right? So we can do this Docker run. I'm just going to start Ubuntu here. Now it takes a little bit longer than Docker on your laptop. In fact, it takes long enough as it tries to figure out where it's going to deploy that in the in our cloud. It's going out, putting that in our cloud somewhere, and I'm going to just do. I'm going to do this and deploy five Nginx containers while we're watching, right? And see what we get. Notice I'm using the -P. We're going to take a look at how that works, but notice that, no doubt. So we saw deployment time sort of jump because of demand. That was a little bit unanticipated. So one of the things that we're still working on is reducing that. But here we are inside Ubuntu. There's some things that maybe look a little bit different. This is virtual Linux. That's cool. So let's clear that. You know what? I want to show you this. This may be a surprise. Look at these two Ethernet interfaces. Now I did this container with a P, and so one of those ETH1, here it is with a fully public address. So that's there. And P, unlike normal Docker, it doesn't remap all the ports to random ports because every container gets its own Ethernet interfaces. There's never a risk of port collisions, right? And so we don't remap any of those ports. Actually, what we're doing, and what you'll see later, is we set up the firewall to match the port specification that you ask for, but we don't remap any ports, and you get access to the entire Ethernet interface. We're taking advantage of the underlying network virtualization in the host operating system that virtualizes network interfaces to every client. And we're not doing any network address translation that you have to do on the typical Docker daemon. And so the performance cost, and we're not virtualizing, we're not doing hardware virtualization of the interface. So we're losing a lot of the costs that come with running Docker, networking over Docker. How many people are looking at microservices architectures when they look at Docker? Okay, I see a lot of hands go up. Imagine what happens if you triple your latency. When you choose an architecture that triples your latency, and you choose an architecture, an application architecture that depends on very low latency communication between its components. That's what happens when you combine Docker and microservices. In every other way, they're ideal, they're wonderful, they're perfect, but from a networking perspective, your ability to get performance is really difficult because of the traditional approaches to Docker networking add so much latency to it. Look at this one over here. So ETH0, we've got that's an obviously private IP address. It's actually totally private, virtualized layer 2 network. All right, so only the containers owned by me can see each other on that private network. If I didn't ask for a private IP address with a -P, I would only get that one, and I wouldn't get a public internet-facing IP address. And so all of my stuff, I have security by default. Public address is only when I request. A question back there.
Can you create additional tenant networks?
Can I create additional tenant networks? Yes. And so you can create as many networks. That's a lie. There is a limit, but you can probably. I would challenge anybody to find and actually run into that limit in a painful way. All right. So. I should be careful about that. So let's do. So we're in Ubuntu here, obviously. What I want to do is just do this. We'll get that, and while that's running, I'm going to go over here. All right, so we've got ourselves some containers, Nginx containers, that is. Let's use Docker inspect to get those IP addresses. You may notice here I'm using our JSON CLI tool to parse the output. I love JSON. I love JSON, and I love our JSON CLI tool because what it meant was I was able to get that information or extract that information really cleanly into just this simple list. And so those 5 Nginx containers, those are their public IPs, and what you'll see is actually it spanned a different range as it crossed the network We group networks, and so your public IP address is not always going to have quite the same pattern. But admittedly, it surprised me when I just saw it. By the way, this is a public gist, and I do these things just because it's it's faster. You guys, I'll share this, I'll tweet out this URL. You guys can go through it. What I want to point out is earlier we were looking at, we were doing ifconfig, and we were looking at the interfaces from inside the machine. The Docker API doesn't give us a way to see that information inside the Docker API. We'd be breaking the Docker API if we tried to squeeze the two interfaces in there, because it assumes that there's only one, and so we could break other things if we added the two. So what we've done instead, we're working with Docker to try and get that in there, make sure that that's opened up and added to the spec so you can add multiple interfaces. But for now, they're only exposed in our in our API called Cloud API. And so here's Nginx 2, and those are the two IP addresses on it in our public API. Let's just try going to one of those. And hey, look at that. Nginx is indeed working right there on port 80, like we figured. You know what we need? Let's see what. Let's see how those are running. And so, what we were talking about is that I have a number of machines running, but those Nginx machines, here they are. And so they're distributed across a few different compute nodes. What I did was I just checked our API and queried which particular compute node everything was on. You got to look for some fine variations in some of the numbers, but if I do that another way, we'll get to count how many different compute nodes are in use. Unique minus C, there we go. So I have those containers distributed, only one container somehow ended up on the same compute node as another. When you do a Docker run, you're positioning that container somewhere on a data center. Now you speak to one data center at a time, but thousands of machines in each data center, right? And so you speak to one data center at a time, unless you use Docker Swarm, which we love. We love Docker Swarm because that allows you to connect multiple data centers. But you do a Docker run, what it does is it deploys that container somewhere on bare metal in that data center. And you can tell here that you're going to be generally on different compute nodes each time. I may have done a thing where one of my containers have a shared volume, and that's really the only reason you're going to end up on the same compute node. We do that anti-affinity by default because that, as we probably know here, is going to be the best for performance and reliability of your entire set. So
is the scheduler pluggable?
The scheduler is not pluggable, but if you want to be specific about how your stuff is deployed, you can be. Not with a Docker API at this moment.
Is your stuff kind of replacing Docker Machine? I don't want to say replace, but it looks like you don't really need to use Docker Machine directly if you're using your cluster stuff. Or your
yeah, right. So the question is, does this replace Docker Machine? And the answer is no. What this does is it changes the way you need Docker Machine, but doesn't replace it entirely. What Docker Machine does for us here is, and it's a pull request that we're waiting to get merged, is Docker Machine add the arguments to connect to our cloud, and Docker Machine sees each data center as a single machine.
Got it. Okay.
And so it configures your environment, and so everything in the Docker toolchain, that's what we're trying to be compatible with in our Docker implementation. We want 100% compatibility with the full Docker toolchain, so that deploying in the cloud really is as easy and fun as it is building on our laptops, right? What do you got there?
Are you doing anything interesting with Docker links, like DNS or messing with XGOs or containers or links? Since you know what other containers are running, what their IPs are, it sounds like it should be.
Yeah. So what are we doing, perhaps to support discovery and make Docker links work better? First thing we're doing, link does not require that you run on the same compute node. The only thing that requires that two containers run on the same compute node is sharing a volume between them. Doing a Docker link, it can be linked across anywhere on the data center, and we're going to see that. All right, Boyd, what do you got?
Does that mean that Docker Compose becomes a far more powerful beastie because the links will go across the sheet?
It sure does.
Well,
Would you like to see a demo of that?
yes, I would. And no, I'm not a shell.
Before we get there, you mentioned sharing volumes
Mhm.
between containers. And that brings up, in my mind, the question of persistence, data persistence.
Yep.
How are you handling those persistent volumes? If the node goes, for example, if for whatever reason the container goes down and comes back up on another node.
Right. So first thing, the container won't come back up on another node. We do not automatically do that. When a container is deployed, it stays on that node until you move it. We don't automatically move a container for you. You can move it. And so that is not a thing. If you're running an additional scheduler that would move it, what you're going to have to do is build into that scheduler survivability or how to bootstrap that container in an environment like that. The data is, the container itself, the data in that container is stateful as long as that container exists. And the great thing is, what we've done is we've eliminated the multiple lifecycle issue. And so when you have a container running on a virtual machine, the container is tied to the lifecycle of the virtual machine. What is exposed to you here when you're running containers natively is that you're working with data that only has one lifecycle issue to deal with. And so until you destroy that container, that data will exist. And so you have the ability to directly access that container, move that data wherever you want in a way that fits your application without the multiple life cycles of the container and the virtual machine, and trying to map and keep that mapping of which container is on what virtual machine. Yeah.
So you completely eliminated hardware failures.
Cool. We haven't completely eliminated hardware failures, but we have relatively few of them. So because the life cycles are separate. Hardware failures are one thing. Virtual machine failures are another. And so what we actually see when you're in virtual machines is because we're virtualizing the whole machine, it actually is subject to crashes independent of the host in the same way. And so we do have situations where the entire hardware crashes. Those are far less common than the guest operating system in a hardware virtual machine.
Casey?
Yeah.
Something as simple as, or I guess probably is with the right word is fleet. We'll move, if you will, the container off of the failed host. That's really a bit of an after-performance information. So is it on the Joyent roadmap to move these things on failed hardware in the future?
So that's an interesting question. The interaction between your application orchestration and the infrastructure orchestration, right? And so what we do is we try to build the absolute best infrastructure. What we don't do is try to dictate how you build your application, all right? And so Fleet actually is at the application layer. And if we look at Fleet, more commonly, and I think a lot more popularly, Kubernetes or Mesos. And I have no doubts that Docker is going to be a very serious player in this business as well with Swarm and Compose. As we look at how those things work, those environments to manage the application are what we want to support with the absolute best infrastructure. But knowing how your application works or dictating how it works in order to support that scenario is a very difficult thing. And so that's where we draw the line between what we can provide and what we want to be excellent at, and what we're looking to support in terms of those application environments that can provide and be excellent at that.
Another question, since you've been talking about how this works, what do you provide in the way of persistent storage?
So all of our storage is persisted on ZFS volumes. ZFS is a file system any familiarity with ZFS?
So if my container goes away, I can still get to my data?
Your container never actually goes away. If the hardware truly goes away, what we're in is a RAID Z, RAID Z2, which is like RAID 10. You have to suffer a lot of disk failures in order to fail out of that. And we have not, to this day, had an issue with lost customer data in a lot of years of running the cloud. So how does that work? Your data is there on that compute node, if the compute node truly fails, the disks are generally recoverable in short order. But we also offer an object store for which we recommend people have a plan to back up their data off the individual machine and back that up for recovery when those disks fail. And so we don't do anything to get in the way of your ability to do that. In fact, one of the things that's awesome is you take a data volume container, plug in what we call plug in Manta Sync, attach that to that data volume, and then you can sync everything in that data volume into Manta, and then you can reverse it to recreate that data volume elsewhere. This makes it a little bit easier than sometimes just pushing that data volume into a private repo, because it gives you a lot easier access to that as individual files, and so there's a lot of easy access to that data. Manta is our object store. All right, so hey, we had a question about Compose. I want to bring this in together. Everybody knows what Compose is, right? Man, seriously, I think everybody's being shy with their hands. Everybody knows what Compose is, right? Okay. Man, thank you. I was like, why isn't he in there? All right, so here's a very simple Compose. We've got console. Console is sort of a key store, but it's better than that. A service database. How about I zoom in there? How's that? All right, and so we've got Couchbase. Now I'm being explicit in mapping these ports open just because, just because I did. So we've got Couchbase that we're going to run, and then we've got a simple container that basically acts as our as an application in that for the purpose of this demo. So I've also got worth showing. This bash script that makes it easy to start it in a very consistent way. I'm going to go through, we're going to look at that bash script as I execute it here. So here's the bash script running. So we do an explicit pull just for the fun of it. So we're doing that pull. We're then going to start those containers. So here we're at this part of it. So we're doing the Docker Compose up, and we're doing it, I'm giving it a prefix that's not the same, the default prefix, and I'm setting a longer timeout, and most importantly running it in daemon mode or detached mode, and doing the Docker up, right? And so we're doing the start on all those containers. First one is console. People know what console is? There's some good love for console here. We like console. Alrighty. I love console. It's got a lot of cool things in it. And so we start with console. You might criticize me that you're not going to see console demonstrated in the HA pattern here, but for the purposes of a demo, you'll forgive me, right? So we're starting console, and then we're going to start the first Couchbase instance, and we're going to start the application. Let me show you what Couchbase is doing when it starts. Well, that was an error.
That's what I'm used to from Couchbase. Either that or it eats my data, one of the two.
Wait, did you say Couchbase or Mongo?
Mongo's web scale, dude. Don't go there.
Ooh.
That means it loses your data fast.
I'm just going to find myself right over here.
All right. So I'm going to start. Yeah, me and VI, we make noise together. All right. So what happened was we had a provisioning failure because we had time while we were doing that, and that's embarrassing. But let's start that again. So I changed the prefix, and we're re-pulling these containers. There's console running again, and so when Couchbase is up, what we're going to start seeing is I've got I did a little bit of a custom bootstrap on Couchbase. First things first, I'm getting some extra details about it, setting some bars, waiting for it to run. Importantly, we check if console is available. So we can't really get anywhere if console's not available, and so we do curl on that just to do it. And if we don't get a result after 7 attempts, we give up. And so there's that. And then once we figure out whether we're in a cluster or not, what we have to do is decide if we're in a cluster. We either, if there is an existing cluster, what we do is then join it. And if there isn't an existing cluster, what we do is wait and re-poll to get there. So yeah. All right, look at this. We got past that error with Couchbase, and so this is good. We got the Couchbase container. We're moving along just fine. So what we do is we look and do this loop to see if there's a cluster, and we just wait in the loop. That bash script that we're looking at, in a moment, what you'll see is, this is the bash script.
Some very precise sleep times. They're like a 1.3 and
okay, so everybody has quirks. I'll admit that one of mine is that I like to have odd numbers, and so if I want, I never just use a 1 second sleep. I have to do like 1 point something. It's more fun that way.
So you're all about the split.
Yeah. So while we're in this bash script, we're waiting for the benchmark container to come up, and for all I know, it's going to embarrass me and fail like it did last time. And so that's that thing. But what we do is once we get there, once we get that running, we wait to be able to talk with one of those Couchbase containers. And so here we are in the bash script on my laptop, waiting to talk with a Couchbase container. And so we just do it. We continue doing a Docker inspect on it. Yeah, we're good. We're good though. I can survive that error. And so we've got we're actually in this, and we're running the bootstrap script. So we'll watch that. And so automatically, what it does is it actually brings up my browser, because that's easy enough to do. Then nobody would ever expose their database to the web like this, but for the purposes of a demo, here we are. And so we've got Couchbase up and running really quickly, relatively easily in Docker. And in a moment, what you're going to see here is that another container is going to come online. Another Couchbase container is going to come online. And it's going to join and join this. Let me actually look back at the cluster overview so I don't save my password there. And it's going to join this particular one node cluster right now. And then add itself and start rebalancing over that. There it is, bam. So automatically join the cluster, automatically rebalancing. And so there we are. Over here, we're scaling to the third node of Couchbase. We can take this pretty high. I mean, we can continue to grow Couchbase as high as you want. It'll spread it over different compute nodes for each of those. And because there's never any worries about the port collisions on the Docker containers, and every Docker container gets its own network interfaces, what happens here is Couchbase, which really depends on having its own control over what ports it's talking on, and doesn't really want Docker or anything else in between of that, because as you create new buckets, you've got to create different ports to talk on. You end up with some frustration in typical Docker networking, where it would typically get in the way. So let's go ahead and do this. Let's just go to 4, just to see that. And so now we're rebalancing across all of those 3. And we'll have that one up and running in a moment. So bam. While it's doing that, actually, I was going to demonstrate this a moment ago before we got distracted. But while we're bringing that up, and actually, you know what? I should be bold. Yeah, I'll wait. So How many people get to run on machines with 48 cores and just see? All right, but look at that. There are actually fewer people using that large machine than there are actually running Docker in production. All right, so props to y'all, and that's awesome. When you're running OS virtualization, and you guys know this because we're here talking about Docker, you don't wrap a VM around the individual container node, unless you do, which might be especially crazy, because then you lose a lot of people. But anyway, the issue here is you actually see all of the hardware. You can't necessarily do bad things to it because we protect you from that, but you get to see all the cores. And so here I just did a 1 gigabyte container. It's our default, and we actually get to run that. But if I'm running, you can see that I've only got HTOP running here. But if I was running processes that needed access to all of these cores, well, these cores are not all busy all the time, clearly, right? All right, so I mean, this one, I don't know what percent that is, but it's not much. There's a lot of available time on this particular compute node that I landed on, right? And so what Joyent does is we give you a minimum compute time, and that's what you pay for when you get that container. If you get a 1 gigabyte container, I believe that gets you half a vCPU of compute time in that process, or on that server. What that gets us, probably waiting for the container to stop. That was embarrassing. Oh, hey, that's because I killed it. I killed that container with a Docker RM in another window, and so we'll get past that. But we don't force you to. We don't hide the available CPU. If you want to use it and nobody else is asking for it, you can burst past that time that you're paying for in that package. You can burst past that and actually take advantage of the entire machine if you want. I'm going to get there.
Do you define what a vCPU is, or are those shares of whatever hardware you're on?
It's a translation of what we know of the hardware to your priority on the hardware and the controls that specify that you're going to get a minimum of that. So knowing how our software works, when we specify that you're going to get half a vCPU, we know that that's what you're going to get at a minimum. Whether you get more than that at any time is up to the circumstances of that particular compute node. Did that? I know this.
Right, but like if are all your nodes basically the same CPU architecture, or do you have heterogeneous ones? That's what I'm asking.
Yeah. So all of the nodes that are running that package are.
Okay.
So yeah, that package is versioned to a generation of hardware specifically for it. But that is a great question. I'm going to get you in a moment. Anybody struggle with Docker's CPU shares? So you do the Docker run -c, and you're like, yeah. Fortunately, there are, I think, 5 pull requests attempting to fix that in Docker itself. Maybe it's really only just 2, and they're competing. Yeah. And so the reality is that very problem, specifying CPU shares in a heterogeneous environment, is crazy. And so what we're doing is it's a modulus environment. Heterogeneous is where it's easy. It's also difficult when you're doing it on multi-tenant hardware, because you may have just one container on there and you want to have a lot of stuff, but getting 100% of the CPU on there is a little bit. You may try to get 100% of the CPU, and that would be buying the whole machine, but that may be not what you want. Anyway, so here we are. We brought up our cluster to 5 nodes. I'm going to do. See if that what that does. It's going to start that benchmark container. What happens is Docker Compose creates the container and then starts it, and we're working on this bug, but sometimes it'll create the container but fail to start it, or time out while it's waiting to start it. So we're going to start that benchmarking container, and then what the heck, let's take that to 7. And there we are with Compose. So how many people know what dtrace is? I love this, and I don't even know if that's the same number of people who know what Joyent is, who knew what Joyent was, but that's awesome. Is it because you knew what Joyent, or because of other things? Smart of us? All right.
I used to do Solaris.
Yeah. All right. So let's go into one of these containers. Man, you guys are supposed to help me from mistakes like that. All right, we're going to exec into that container. And what we're going to do is we're actually going to take a look at how we're running dtrace inside, where we have dtrace inside that container, right? So let's see if we've got, we're indexing, this is cool, we've got what we need there. So the whole, all of the commands that you would expect under SmartOS that are part of, oops. Wow. Well, I'll admit I had not tried it inside the Docker container, but there we go. We can still run it. I don't know why which is failing, but big deal. Before we get to that, let's use PRStat. And so we can see Couchbase is doing a lot of stuff. We've got a lot of Couchbase processes while it's doing this stuff. And so with PRStat, we can see a lot about what's going on. But that's still not quite as cool as running dtrace. So I'm going to run this one. Bam. We'll see what happens. I have not run dtrace on Couchbase yet. So I don't know what this is going to come up with. Who wants to find out? So Couchbase, it's been doing some indexing and rebalancing across 6 nodes here. So here is what dtrace was doing all that time. So those are the different system calls being made along the way. And so when you're seeing performance problems, you get visibility, you get introspection into what's going on in your container that you've probably never had inside Docker before. And so we are in that container, we can look at every call that's being run and everything that's happening to in the lifetime of it, or in the time that you're watching it anyway. So cool, right? Alrighty, we've been at this for about an hour. What else can I show you? What do you want to know? Yeah.
I had a question going back to the first one that we're talking about.
Mm-hmm.
Is there any way to prevent the burst mode? Let's say I want to simulate like my container I allocated. I want to simulate the minimum performance of
Right.
my container. So I don't want to measure when it's bursting, right? When I get more resources than it asked for.
Right.
Is there a way of doing that?
And so the packages that we have in our public cloud don't do that. But if you're running our software to power a private cloud, you can design your packages any which way you want. And so you can specify that bursting is not allowed in a package in that environment. And you can do just that. Yeah. All right. What do you got?
Can you specify the pin to a specific CPU if you're running locally?
Can you specify that it pinned to a specific CPU?
Or just a pin to a CPU? You
Yeah.
know, swap in between.
So you can specify that in the container environment. Our Docker implementation doesn't support that directly, but you can specify that when you're working with zones. I'd love to know more about the use case that you want that for. A common one is because, well, you may have memory attached to specific locations that are there. And so we automatically, the scheduler, the OS, automatically optimizes for that particular case.
Okay, so you are aware.
Yeah. Yeah. So if you really wanted to, you could, but what you lose is a lot of elasticity in that machine, and so we'd advise not doing that. Especially because, you know, if you get a 48 CPU machine or 24 with hyper-threading, you can enjoy a lot of flexibility to move things around on any available CPU. For a lot of things that are not memory intensive, that's a performance advantage to them. Yeah. All right.
At the beginning of the presentation, you were saying either your guys' data center or your own data center. So is this a product that you could spin up your own data center, and would you get your software and throw it in a bunch of machines, or I'm just curious?
No, that's a great question.
Yeah.
And so here's how it works. It runs on, it starts with bare metal. Let me go to the GitHub repo. So it runs on bare metal or inside your laptop. All of our development starts inside an environment that we call cloud on a laptop, and so that's it. So getting started here, the primary environment for a lot of people, first steps are in Cole, and so we step you through installing it inside VMware, and then installing on a physical server. And so what you missed is actually last night I did an install on hardware right here.
Oh, those are 34 minutes?
Yeah. So I brought it up. I had brought in hardware. I had everything that you'd expect in your data center. I had a core router, a really cheap router. I had top of rack switch, which was a fairly cheap switch. And I had these 3 Intel NUCs, only 2 of which I used. One of them was the head node, and you install the software on that. And once you get it configured, that took however many minutes. Then you plug in your compute nodes, and as you add those compute nodes, they actually automatically net boot and join into that environment. And so you can add compute nodes bare metal, just from racked to running in about 60 seconds, and so that's about what it takes. We do that because this is the software we use to automate our data center. We don't have time. We're a small company. We don't have time to spend trying to rack things. You got to rack them, but we don't have time to waste post-rack trying to get things up and running. So automating that's what we do to get the infrastructure. We want to own and provide the absolute best tools to get you from bare metal all the way out there to running containers as infrastructure for your environment. All right. Other questions? So you know what I didn't do? I realized I didn't talk about the spectrum of what containers are. And we've been talking about Docker a whole bunch, and I love it. And don't get me wrong, I think that approach to things is going to be the long-term winning approach. But for a lot of us, I asked earlier, how many people are running Docker in production? Here's a different question. How many people are running virtual machines in production or any real hardware, bare metal hardware in production? Okay, I'm going to assume if your hand is not up, you're looking for a job. Alrighty. Sorry, I don't mean that as all critically. I mean it with love. But what I mean is there's the spectrum from what we learned. This is what I talked about earlier. Joyent has been using containers on this side. Containers as an alternative to virtual machines. All right, but on the other side are application containers, and this is what Docker has definitely introduced us to. But that's a spectrum for how you can use containers, right? And so on that spectrum, we have what we call infrastructure containers, right, where you get all of the services that you'd expect of a Unix host running in a VM. And then there are Docker application containers on the other smaller side. Of course, in the middle, they meet, right? I mean, there are lots of people trying to run multi-process Docker containers, and we certainly do infrastructure containers, trying to make them as thin and application specific as possible. Actually, the software that runs our data center installs like 35, 40 different containers, some of them as small as 256 megs, and they probably could be smaller, but they're designed to run at large scale. So we assume some things necessary to, some larger than necessary defaults, I think, for the install that I had with 2 nodes yesterday. And so all of that, we do a very, very microservices application-specific implementation, but inside infrastructure containers. So they're, down around here somewhere, and fat Docker containers maybe around here. So that's a spectrum that we should keep in mind. You can get all of the advantages, performance advantages that I'm talking about containerization, without necessarily having to Dockerize. You can use infrastructure containers to enjoy the performance benefits of running on bare metal and getting both the elasticity and the performance of bare metal with none of the security costs of going on bare metal and typically losing the virtual machine wrapper. We already did the demo. So thank you. Thank you all for coming tonight. I will be taking questions on that, but I want to make sure that we get to beer ops with plenty of time to enjoy. Just remember Joyent for what we're talking about.